today we're going to be working on fundamental problem 2.2 to determine the magnitude of the resultant force if F1 equals 250 newtons and F2 equals 540 newtons. So the first thing that I like doing is to help me find the magnitude is I like drawing the given figure that we have into a parallelogram. So what we're going to do is we're going to take these two forces that were already given to us and we're going to draw them to the side, off to the side. We're going to just draw them here to the side. I'm going to take the other force and move it to the side as well. And then you could label them already, just so you don't get them mixed up. This was F1 and this was F2. Okay, so now what we're going to do is to finish the parallelogram. What we do is we take this force right here, F2, and we're going to draw it on the other side from the tip of F1. So we're just going to draw it. And then the same thing with F1. Just gonna draw it starting from the tip of F2. And by doing that, we now have a parallelogram. From here, we could also label these ones. So this one was F of 2, and then this one was F of 1. Okay, from here, we know that this angle right here is this angle right here, and that is an angle of 40 degrees. So we could label that right here. And since that angle is 40 degrees, we know that this angle right here is also 40 degrees. From there, the only thing that's missing are these two angles, which we know that are going to be the same. So what we know is that the sum of a parallelogram has to equal 360. So 360 has to equal 40 plus 40. And we're going to name these two missing angles beta. And we're going to go back over here and then plus beta plus beta. Or you could simply write that out as 2 beta. So then you have 360 is equal to 80 plus 2 beta. And then that gives you beta is equal to 140 degrees. So now we found the value of these two angles right here, which is 140 degrees. So now that we have that information, we're going to find the magnitude of the resultant force. And to do that, we're going to use the cosine law to find our magnitude. And rewriting the cosine law just a little bit, we're going to get this equation. F of r is equal to f of 1 squared plus f of 2 squared minus 2f of 1 times f of 2 times cosine beta. F of r here signifies or represents our resulting force. Then we have our f of 1, f of 2, and we already know what beta is because we solved for that earlier. So all that we have to do now is just simply plug in our numbers into our equation. So f of 1 was 250 newtons and f of 2 was 540. So 250 squared plus 540 squared minus 2 times 250 times 540 times cosine, and beta was 140. And then from there, all you want to do is plug it into your calculator. One thing to note is that we got to make sure that our calculator is in degrees and not in radians. So once we input that into our calculator, we should get that our magnitude of our resulting force is 748.95 newtons. And just like that, we found the magnitude of our resulting force. So if we were to find the direction of the resulting force, that would require the sine law. But here they only asked us to find the magnitude and not the direction. So simply by using the cosine law, we were able to find the magnitude of the resultant force.